Okay, so let's do a practice problem with the second derivative test. This question goes, use the second derivative test to determine any relative extrema in the function f of x equals 4x cubed minus 6x squared minus 24x plus 1. Okay, so the first step of this problem is to find the first derivative. So f prime of x equals 12x squared minus 12x minus 24. Okay, now we can set the equation, which we can set the first derivative equation equal to 0, because we know that the first derivative has to be equal to 0 for the second derivative test to be applicable. So 0 equals 12x squared minus 12x minus 24. All right, so now we can simplify this equation by taking out a 12. So we have 12x squared minus x minus 2. Okay, so now we need to factor this equation. So we need to find two numbers that can multiply to negative 2 but add to negative 1. And those numbers are negative 2 and 1. So now the equation can become 12x minus 2 x plus 1. And then we separate this equation. So 12x minus 2 is equal to 0. And 12x plus 1 is equal to 0. So the number that you can plug into this first equation is 2. So we know that x equals 2 here, because 2 minus 2 is 0, and 12 times 0 equals 0. And then using the same logic, x over here is going to be equal to negative 1. So now we have both our critical values. So now we need to find the second derivative of this equation. So f double prime of x equals derivative of 12x squared is 24x, and the derivative of 12x is just 12. So we have 24x minus 12. Now we plug in our critical values. So f double prime of 2 equals 24 times 2 minus 12. That becomes 48 minus 12. You get 36. And the same thing for the other critical value of negative 1. F double prime negative 1 equals 24 times negative 1 minus 12, which gives you negative 24 minus 12, which gives you negative 36. All right, so now we know at x equals 2, because 36 is the second derivative, because 36 is f double prime of 2, and it's greater than 0, we know at x equals 2, there is a relative minimum and we know at x equals negative 1, because negative 36 is less than 0, there is a relative maximum. So if the second derivative is greater than 0, we know it's a relative minimum, and if the second derivative is less than 0, we know it's a relative maximum. All right, thank you for listening.